Hi everyone, I'm Richard. Good to meet you. This will be a nice quick run through, I hope, and lots of chat, because one of the main things I want to do is present where we are and the journey we've been on and really get some good feedback from you about where we are and where we might go next. So the title is Exploring Open in Energy. I have a subtitle, which is that. So I'll explain what it is. So our open source bit is the Fuel Cell Developer Kit, FCDK. So we're going to focus on that, but I'm going to give you a bit more background about who we are as a company and where this all fits in the bigger landscape. So a bit on technology, a bit on our journey so far, and really an interactive thing, discussion about what next. So Arcola Energy, we're based in Hackney, up in Dalston. We've had some grant funding from Innovate UK to develop some core capability around fuel cells and hydrogen. Part of that has been working with guys at Imperial College, UCL, Warwick Manufacturing Group, really good partnerships with universities. And also, as you'll see, some lead customers of some of the technology, particularly in the vehicle side. The thing that we do is we're a system integrator. So we take fuel cells from other people, although we do our own development of the core technology of fuel cell. But mostly we take other people's systems, or stacks of the fuel cells, and turn that into useful things that does stuff. Everything up from watt scale all the way up to kilowatt. The odd thing about us is that we're based in a theatre. Arcola Theatre is in Dalston, officially off West End. We're up for the most of the Offies Awards this year of any other theatre in that group. And we do really interesting theatre, and I recommend, if you're into rugby, the play about Gareth Thomas, the Welsh rugby player who came out, that's on in April or May, I think. I'm looking forward to that one. It's an interesting place to be. We use the theatre building as a demonstrator site for renewable energy technologies. So we're doing communication, got public engagement, we do education work with our educational teams from the theatre side, and we're also an engineering business. So a very unusual sort of organisation. So this is the small scale stuff that we do. This is the developer kit that I'm going to come back to. The open source bit of it, if you like, is our board. So it's the control bit, which means that when you buy your expensive fuel cell, you don't just end up with a lump of metal and platinum and membrane. So we'll actually control it for you so it doesn't break. And then there's some hydrogen stored in these metal hydride sticks. And as you'll see, you can do very simple and quite elegant things with that very quickly. We built that train for James May as part of his Toy Stories program. It ran all the way across Devon. It won the competition because it went further than the batteries. That's where hydrogen wins. And we built that in a weekend with our system. Slightly bigger scale, system integration. There's a fuel cell in the bottom here you can't quite see with some hydrogen. And that's on the Top Gear track up at down in Guildford, near Guildford, powering off-grid lighting tower. Again, a really good use for hydrogen, going remote places. That will run low power for a while. And you know, because it's hydrogen, it will again last longer than a battery. If you just add more fuel, and it lasts longer. And again, we're doing the integration of bigger fuel cells, kilowatt scale, into these early stage developer vehicles, lightweight vehicles, some of which you might have seen. So that's kind of what we do, is a bit of background. Going slightly bigger scale, what about fuel cells? They're one of these great technologies that's been around for a very long time but not really gone anywhere. And first real application of them was on the Apollo missions. But it's been one of these things that have been through several hype cycles, and there have been a lot of equity sunk into fuel cells, not really gone anywhere. Huge amount of investment, and the state of the market now. Cars are coming. You'll see Toyota Mirai on the news quite a bit, probably. They're coming to Europe fairly soon. Lots of them being sold in Japan and the US. Hyundai also got a vehicle on the market that's probably running around London, some of those at the moment. I drove one a week ago. It was up in Sheffield with a partner. Telecom's back up, very slow, like the market. US has done a lot of materials handling, forklift trucks. But it's slow going. Finding where it actually works commercially, because they're still very expensive, is quite hard. And so the problem is you end up with all these companies going around thinking there's a market out there and locking up their IP really tightly and not talking to anyone because they think that if they do, you've got to go through a beauty parade or be someone really exciting for them to work with so their investors are excited. So we're wanting to take a different approach and be much more open and engage with much more people and build a bottom-up market, if you like, or community around fuel cells. People who understand the technology will use it. We're doing a lot of research, working with universities, partnership stuff, trying to join different organizations together rather than just do it all ourselves. And exploring where the market is, exploring where fuel cells and hydrogen works. Let's just try some things out quickly and easily. And that's where the developer kit really comes in. You can do rapid prototyping very quickly. And we're building the company roughly doubling every year based on just organic growth and contract work. So the developer kit, open source. At the moment, we have the software is open. We're just looking at what the licenses are for the board and how to manage that. Again, that's something we might discuss. It pairs with the boards you'll be familiar with. It's the bit that stops the fuel cell breaking. And those are the sort of things that you can be used for. Exploring with you whether this is something that's relevant to some of the projects you're doing or interesting to you. Things we've done already, if you know Andy Stanford Clark from IBM, he's got a couple of these and he's paired it with a Raspberry Pi. He runs his presentations on hydrogen. Pi boots up off a stick, memory stick, but and he talks through the process of how the fuel cell works as he does his presentation while the Pi boots up. And we gave him a little case because he goes on talks and takes it all around the country and does his presentations and takes his hydrogen with him. You can take those on a plane, only 2 of them though. Hashtag HiPi, you probably find some of the other things. Various places he's been. He was at one, I think where was this? This was at OSHUG camp up in Oxford. And there was a guy with these high def screens and he just plugged it into that and powered the presentation and so on off the same board. And this other one, that was a company doing the panels on aircraft seats, and he just plugged the fuel cell and the Pi into that and powered that as well. So what's that useful for? Don't know, but it's just fun. So from that development, the work that he's done, he added a few features to it, put his own little board on top, a little blue button to press go, and that's going to feed into what will be our next generation board. So we've started to explore how we can work with others, open up what we're doing, and just engage with a wider group of people to say, how do we make this better? Really interested to explore with the open source hardware community where this might go. So why would you do this in energy? Let's again open up the perspective a bit. So the old model for energy systems is central generation, distribution from there out through the network, and everybody then, these are the electrons that are coming towards you. You adapt at home to what you've got. You put a plug on to adapt to charge your phone, or you run off 240 volts or whatever. The new model is much more dynamic than that. So you've got distributed generation with solar, wind, maybe fuel cells on the edge, multi-directional flows across the network. You've got local networks. So in the theatre, we've got a DC grid with energy storage. And that's going to be much more common. And the problem is that with that, you've got to have the network adapting. So the adaptation often happens at the network with people deciding what they want to do locally. So it's a very different landscape, particularly this distributed generation, and the impacts that has on the model. And then there's digital disruption coming in with some of the tools that are there. And I'm sure you'll be familiar with them. Many you will have looked at what you might do with hardware and things to play with in that energy space, control systems for the home. But I think where we're kind of interested is what do you do with the generation? How can you prototype things in a quick way to explore how local generation works, even at what scale, in a distributed grid? How can you fill in gaps? Can you do frequency response? That sort of thing on a network is quite interesting. And our fuel cells are model for what you might do with bigger systems. because they're quite nice and quite easy to control. And you can do more with them as a generator than perhaps you would with a battery. So where are we? So we got version 1. We've sold about 50 of them with the kit, the whole caboodle. The source code is open, but not yet with the board design, but we're looking at the models and the licensing around that. We've started to develop some open partnerships, and we'd like to take that further. And we're starting to build from those relationships what might be the next generation of the board. Our own tinkering is saying actually this and this would be good to put onto that to go to the next version. So some of the challenges that we face, we're not in the let's make this as cheap as possible, because it doesn't really work. It's not a £10 board because the fuel cell is £300, £400, £500. So it's quite a chunk of cash. So that full kit, that's the current prices. I think that's a bit of a snip at the moment. I think our fuel cell prices have just gone up, and those might need to edge up a little, so get some quickly. There's a pricing issue. So the sort of thing you can do sensibly, the one that Andy Stanford Clark has to power Raspberry Pi very comfortably with the 12-watt system. That's 375. 30-watt, if you want to do a screen as well, you might need that. It's obviously a bit more pricey. The problem is where you're getting your hydrogen from. You've got a stick, and that will last you at a few watts, several hours. But you've probably got to, and you get several of them. It will last as long as the hydrogen runs. But at some point, you are going to run out. Where do you get some more hydrogen from? So you can buy a little electrolyzer that sits on your table. But again, that's another 600 quid. You could share an electrolyzer. Maybe there's a group of you. You're all going to have a developer kit, have some fun. Share one electrolyzer and someone do refills for you, or just pop up to Dalston and we'll fill some up for you and send it in the post. It might be easier in the short term. So exploring those models, particularly that one, see if you're not a bit like what Love Film used to be. Send the CDs back to us, a couple of empty Hydra sticks, send them back, we'll top them up for you. So those are kind of specific issues that we're facing. And then there's the general open source hardware questions that you'll be familiar with, perhaps particularly if you're building and developing your own, and the costs of the board and the cycle times for the versions. What's the licensing model? What's the business model? So that we as a small company of 13 people are not just going to get wiped out by somebody else, and actually going to survive and have some cash to carry on doing what we're doing with our other areas. So finally, then I think where we would like to go, as the core board, we would like to really get that out there and start engaging with people, enabling a much more open engagement around fuel cells and hydrogen technologies. So we want to put the fuel cell, the hardware, the board rather, as fully open hardware, and do agile co-development of that board with the community. We'd like to get a point where we've got relatively short cycle times for version production, and that might be by doing quite simple prototyping ourselves before we get to the stage of sufficient volume to be able to get that out more widely, or into production rather. And then I think the interesting stuff comes when, okay, someone's had a really good idea, and could be a product. Well, can we do that, work together? Our experience of doing some manufacturing and working with fuel cell product development, can we take that together to market, do some design, implementation, product development, the integration you'll need to get it to a product level, and then a joint route to market. Because really what we'd like to see is let's explore also applications of fuel cells and hydrogen. Where do they work? Sort of things that the projects that you've got already, you think, actually, for what I'm doing out in this particular thing, that might work. Maybe, I don't know, sensors, is that somewhere where it works? Environmental monitoring. Maybe you want to run your own Raspberry Pi and a screen for when you're camping. Who knows? Is there a market for it? Can you find other people also interested? Let's use the widest possible resource to explore this. Is where we'd like to go. And we're developing on a bigger scale. We're developing our, it's this sort of size, the kilowatt scale system. Can we adapt a model that we're using at this small 1 to 30 watt scale up to kilowatt. And I think that would be quite disruptive to what's a very closed fuel cell sector. We'd like to have some fun with that. So that's kind of where we are. It'd be great to have your feedback and comments on that, or any questions you have. Or really, does this matter? Is this of interest to you, or is it just completely out there?
Okay, questions for Stan?
Yes, sorry, butting on the first one. What's the effective self-discharge time on one of those sticks? How long does it last before it discharges itself?
It won't. No, well, there's a pressure vessel, so you actually need the regulator on there, and it releases the valve, internal valve. So.
But won't the hydrogen eventually percolate out through the metal?
No, I don't think so, because it's got an aluminium skin.
You don't get through anything, but anyway, it's not very fast.
Not very fast, not that we've noticed anyway.
An application which might be interesting.
Yes. Great.
Your limit's about 10 years on battery applications, because that's what the best batteries will last for in the commercial context. So you can beat that.
Yes, I mean, this is where.
You don't even have to beat it. If you're doing better than a couple of years for, or a year for hybrid NIMH, for example, you're already ahead of much more competition.
So it comes down to quite a complex question of volume, power, and energy, and weight. And it does depend on the power of your application, how quickly you're running it down, and what size of battery that needs to be to match that. So there are people running up and down the highways putting many kilograms of batteries out to look after systems. And yes, that could be optimized from an energy use point of view, but actually it'd be a lot easier to use a fuel cell for that.
Weight just seems to me to be a very important point.
Yeah.
Richard, firstly, roughly what size are the anhydrous capsules?
They're about that long. Yeah, sorry, I should have brought some with them, but but they how long's a piece of string? So those particular hydride cylinders are yay big. You can get another one which is 10 times as much hydrogen, which is that big, and then you can have a full cylinder, which with that watt system will last you for years.
And of that size cylinder, roughly how many watt-hours of electricity do you get out to the other end of your...
Yes, I knew you were going to ask me this.
I mean, I'm trying to get a comparison between that and, say, the energy density of, like, lithium-ion or that sort of thing.
Yes.
You said a few hours on
yes.
1 watt, didn't you?
So there's a few hours at 5 or so watts. So I think those are something like 10 watt hours.
Okay. And that's after the fuel cell conversion efficiency?
Yes, which is about
50?
Yeah, roughly.
So
Yeah.
you've got an energy density several times NIMH.
Yes. Yeah.
Well, that's very interesting.
Yeah.
That's the critical one, is the energy density.
Well, some applications for the one I've got in mind, it doesn't really matter, but the fact is it's not hugely the wrong way. It's
Yes. Yeah. Absolutely. Yeah. You know.
So the development kit board you're talking about, is that dealing with the safety critical aspect of it? What kind of hardware you built to deal with it?
It's more about management of the fuel cell so you don't kill it, and the power conditioning. So there are certain things that you do to look after the fuel cell. There's some short circuiting that happens every few milliseconds. No, every few seconds. And there's amount of control. So there's not so element of safety, yes, but more management of this expensive lump of hardware, which is the electrochemistry.
What's the lifetime of the hardware? And what of that lifetime, if you amortize it, what's kind of the cost per kilowatt hour of the electricity? It'd be very difficult to say. I mean, they will degrade over time, but we've not. So the 100 watt system, the 150 watt system, we've had running for about 8,000 hours, and there's a small curve of degradation, but you don't really notice it. So on the other hand, the reason for the control system is what you're more likely to do is to break it. So if you're using it normally, then
yes, that amortization is over quite a long period of time.
When you talk about £200 kit, almost all that £200 is just the fuel cell.
Roughly, yeah.
And those cylinder things was just the store of the hydrogen.
Yeah, so the cylinder things are about 15 quid each. Our board, I can't remember what we priced that as. At that sort of volume, it's probably about 50, 60 quid's worth of board.
Given the amount of rain in Britain, could you use rainwater to produce hydrogen and have a sustainable system?
So there are people that have looked at that. So often in a remote place, actually what you want to do is have an electrolyzer and a fuel cell, so for a backup system. So there are people that have taken rainwater, renewable energy source, an electrolyzer, yeah, absolutely, and then created the hydrogen, stored the hydrogen, and then use it in your fuel cell. And it's self-regenerating system, if you like.
There's a multi-megawatt thing in Germany which is plugged into the grid, which pushes hydrogen into the natural
Absolutely,
gas. So, you know.
yeah.
And that then don't have a fuel cell system they're selling that uses seawater.
Yeah, I need to look at what the chemistry of that is, because actually I don't think that's a fuel cell, I think that's a battery. They're just adding electrolyte. You can't use seawater as a fuel.
So that led on to the next question. Your fuel cells are very expensive because they have precious metals in them.
Yes, so platinum is the catalyst for the hydrogen and oxygen reactions.
So at the end of its life, it still has metals that can be recovered.
Yes, and there are people, partly people that we're working with who are looking at what that process is to extract the precious metals and actually some of the other materials that are in there as well. I think whole circular economy thinking is going to be quite important to the full commercialization of fuel cells. Yeah, so there are people looking at non-platinum catalysts, so rhodium covered with platinum is one way people are looking at that. There are palladium versions as well, not necessarily non-noble metal. But
You talked about licensing.
yes.
What options have you explored?
So early days, but looking at, well, do open source software licenses apply? What are the open hardware licenses out there? It'd be very interesting to see.
Experts in the room.
Right. Be very interesting to talk to you if you're looking at this, because it's experience of others would be extremely valuable.
Solar panel, and then looking about the hardware licenses, a lot of the expertise comes out of the UK.
Right.
And
That's good to know.
That they have gone to some effort to learn from software and actually make it compatible. So there's the CERN open hardware license,
Yeah.
which is compatible with solar pad. And I think they're even trying to make the US took some amateur packet radio open hardware license.
I did have a look at that one. Yes.
Compatible, but that's more patentable. But there are people
So-
out there, particularly Andrew, I think.
So it'd be interesting to hear from the floor. So if you use the open source software licenses, you're protecting potentially your designs under copyright law. Is that
Solar pad is Apache plus, and Andrew will tell you things like the design rights and manufacturing rights. Well, it's essentially Apache 2 plus the things you need for
protecting the hardware? Yeah.
Well, or to allow you to give them away.
Yeah.
So
Yeah.
people feel they can use them.
Yeah.
So we're putting all our hardware design on the solar pad,
Okay.
and everything else in software is Apache, and then it's all basically one license with
Yeah.
some extra bits on the side.
Yeah.
The problem with solar pad is that it's not very familiar to people. And then if you want adoption
Yeah.
by industry, then they would have to have their lawyers look at it. And but Apache, MIT, they'll be much more familiar with it.
But note the solar pad says that you can just read it as Apache and use it as Apache
I know.
if you want explicitly. So, I mean, that.
I-
Difference between Apache and solar pad is a sentence or two.
But the other thing is that that's one of the merits of the CERN OHL. CERN carries a certain amount of clout. If CERN
Yes.
it must be good. We had Andrew Katz over a year or two ago to OSHUG, which is the lawyer behind a lot of this. And I think the point being made is that all these licenses have graduated down to the fact that you've got to rely on copyright law,
Yes.
on the documentation of the design, and that's the way you try and protect it.
Yeah.
Because once you go down the TAPA route of going into patent law, you become jurisdiction specific, and patent law
Yes.
is expensive.
Yes.
That's interesting. Well, I think it's probably fair to say that it's still unsettled. You know, there's no GPL which is taking over.
Not enough people are doing don't mention GPL and better.
Well, I know. Sorry.
It's probably some more people need to do it. I feel very
Yeah.
confident we can do solder pad. It won't hurt us because it's essentially a patch under the covers.
Yeah.
People understand that all well enough.
Mm.
You have the challenge of there is no true full copy left.
Yes.
Open hardware license because of the difficulties of doing it for hardware. And GPL says don't use us for hardware, it's strange.